Hey guys, Mrs. O'Donnell here. Today we are going to solve quadratic equations by factoring. Our goal is to solve quadratic equations by factoring. All right, we have a cram-packed week. Please make sure you're coming to office hours with questions. I'm here, I'm available. You could even potentially get to chat with my crazy kids for a minute. Okay. All right, so just again, a reminder that when we're solving quadratics by graphing or just in general, we're looking for those x-intercepts, right? We're looking for those roots, those zeros. We're looking for where that output will be 0 on that x-intercept. We can have two solutions, one solution, meaning it only touches the x-axis one time, or 0 solutions. All right, so let's consider the system of equations graphed below. When answering the following questions, be sure to consider the key characteristics like intersections, vertex, roots, and intercepts. This is an activity that I typically give as an investigation, but since we're doing distance learning, we can't quite investigate the same way we would in the classroom. So again, I'm going to encourage you right now, go ahead and pause the video. Check out this page, see what you can do on your own, and then come on back and we'll check answers. All right, so for those of you who are just coming back, those of you who maybe never left, let's check out what's going on here. So it looks like on the left-hand side, we've got this function, f of x equals 2x squared minus 8x plus 20. Okay, and that's giving us this quadratic or this parabola that's graphed nicely right here. And then it's also saying, okay, find when you've got both of these functions. So at what point do you have both functions being satisfied? So our second function here is f of x equals 5. All right, so f of x equals 5 is this nice horizontal dashed line. So they've created a quadratic and a linear system of equations. And we have to remember when we're graphing or solving a system of equations, what do we look for? The intersection, right? Or that overlap. Okay, so it looks like our solutions to the system would be at 3, 5, and at 5, 5, it looks like. And if I'm just recording the x values there, my x values are going to be 3 and 5. All right, now let's check over here on the right-hand side. We're given this function x squared minus 8x plus 15, and they want to know the second function or the linear function there is when g of x equals 0, right? So we're given this nice big parabola graphed right here, and we're looking at where g of x is equal to 0. Okay, and again, it's a system of equations, so we can go ahead and look for that those intersection points. It looks like we've got an intersection point right here at 3, 0, and another one right here at 5, 0. Okay, and if we write down just our x coordinates, that would be 3 and 5. Okay, so all right, what do you guys see, notice, and wonder? This might be another good point. Now we're all caught up. Hopefully your answers are checked. Take a minute, write down some things that you see, notice, and wonder. Pause the video, come right back. All right, what you might see, notice, and wonder at this point is that, hey, our x coordinates are the same for both solution sets, right? So even though our pictures look very different, okay, our x coordinates are actually the same. Okay, our y coordinates are the same within their solution set, right? So I've got an output of 5 and output of 5. Here I've got an output of 0 and an output of 0. Okay, you might have noticed that. Okay, and you may wonder what is going on here that we see these different patterns. All right, so again, go ahead and pause the video, try and answer these questions, and then come right back and we'll check your work together. All right, so You may just be coming back with your work completed. You may already have it done, but let's read through this together. It says our f of x equals x squared minus 8x plus 20 and g of x equals x squared minus 8x plus 15 equivalent functions. Why or why not? How do you know? So this is where we could say no, they are not equivalent functions. They are not equivalent because their tables, their input-output tables are not the same. Okay, their outputs and inputs are not the same. They're not identical. Okay. All right, so what do you notice? And we also may notice, if you go back to that previous page, the graphs were not in the same spot. They have to be in the same spot for them to be equivalent functions. All right, so what do you notice about the algebraic expressions below? Are they equivalent expressions? Is one expression easier to solve algebraically without graphing? Explain your reasoning. All right, so it looks like right here we've got 5 equals x squared minus 8x plus 20. And we also have 0 equals x squared minus 8x plus 15. Well, what do you guys think? Is there one that you know how to solve? I would say right off the bat, I could solve this x squared minus 8x plus 15 by factoring it, right? I know that 15 factors down into 5 and 3, and I've got my factored form. And from my factored form, I know I can use that zero product property, and my solutions are going to be 5 and 3. So I would say this one's probably a lot easier to solve. Okay. Could we solve this equation over here? What do you think we could do? Okay. We could get rid of that 5 by subtracting it, couldn't we? And then what would happen? We end up with 0 equals x squared minus 8x plus 15. Okay, interesting. So at this point, maybe you're starting to have an aha moment. Maybe you're starting to notice, oh, okay, I just subtracted 5 and I ended up with an equivalent expression. Okay, what property helps us solve quadratic functions algebraically? That's what we already talked about right here. That would be the zero product property. Okay, and how does that property affect the approach to solving 5 equals x squared minus 8x plus 20 algebraically? Well, in order to use the zero product property, our function has to be set equal to 0. So we had to subtract that 5 from both sides of our equation to get a function that was set equal to 0. Okay, and then we were able to go ahead and solve algebraically, right? And it would end up looking just like our right-hand equation here. We would factor it, and our solutions would still be 5 and 3. Okay, something else that you may have noticed, if you popping back over here to this slide, you may have noticed that our parabola, right, our x squared minus 8x plus 20 is a transformation, okay, to this x squared minus 8x plus 15. If you just go down 5, you get from f of x to this g of x over here. Okay, so going down 5, you get that, you have that transformation. So they are almost equivalent expressions. They're just transformed. All right, so let's take a look at solving by factoring, right? So now that we know, we have a pretty good grasp on that zero product property, and we know that what we're looking for when we're solving our quadratic equations is essentially where they're crossing that x-axis. So we need to get this into standard form set equal to 0. So I'm going to subtract 12x. If I do it from one side of my equal sign, I have to do it to both sides of my equal sign. Oops. Like that. There we go. It's a little neater. So I end up with x squared plus a negative 12x plus 36, and that's equal to 0 right there. And now from here, I can go ahead and grab my box, do my box method to factor, right? So if I'm trying to factor this out, I know I've got my x squared, I've got my 36, I know x times x makes x squared, 6 times 6 makes 36, and if I make those negative, am I going to get that negative 12x? Let's see here. X times negative 6 is negative 6x. X times negative 6 is negative 6x. Add those together to get that negative 12. So it looks like we've got a perfect square trinomial. So I've got x minus 6 quantity squared. And I can use that to figure out my factor. When you have a perfect square like that, you do only end up with one factor. You're touching the x-axis in only one spot. So x is equal to 6. That would be my solution. Okay, and you could go ahead and grab your graphing calculator, hop onto Desmos, and test this out by graphing it. See what you get. So like I was saying, if you wanted to check your work, right, graph your system of equations, you've got x squared plus 36 is one of your functions, and you've got 12x. And it's a little different than looking at just your x-intercepts, but we did do this with one of our exponential functions. We did that investigation, and you'll actually see that intersection is 672, but what you're really looking for is that x coordinate here. Okay, so that's a great way to check your work. Hop onto Desmos. All right, let's take a look at another one. So here I've got x squared plus 4x equals 0. So it's nice because it's already set equal to 0, so I don't have to figure that part out. And then I also see, hey, I only have two terms here, and they both have an x in them. That tells me right off the bat I have a greatest common factor. So I can factor that GCF out, and I'm left with x times x plus 4 equals 0, and from this point, it should be really easy to use that zero product property. Set one factor equal to 0, right? Set the other factor equal to 0 and solve if I need to. So in this case, I have to subtract 4 from both sides of my equal sign, so x equals negative 4. So that tells me that my two solutions are 0 and negative 4. For x squared plus 4x equals 0. Okay, then I can hop over to this next one, give it a try. I've got x squared plus 7x equals negative 6. Again, I have to make sure that my equation is set equal to 0, so it's in standard form. So I'm going to get that 6 over onto the left by doing the opposite, which is adding 6 to both sides of that equal sign. So when I do that, I get x squared plus 7x plus 6 equals 0. And again, I'm going to grab that, make my area model, my box, x squared. I know my 6. I know my diagonal is going to add to make 7x. So I've got x times x, 6. Let's see here. I could do 2 and 3 or 1 and 6. I know I'm trying to make 7, so I'm going to try 1 and 6. Whoops, not 7. 1 and 6 there. All right, so 1 times x is 1x. X times 7 is, oops, gosh. X times 6 is, let's fix that. X times 6 is 6x, and that adds to make 7. So I know my factors are x plus 1 times x plus 6. And using my zero product property, I know I have to set each of my factors equal to 0 to figure out what my solutions are. So I'm going to subtract 1 from both sides of my equal sign, x equals negative 1. Subtract 6 from both sides of my equal sign, x equals negative 6. Again, check your work by using technology, hop onto Desmos, graph it, see what you get. And don't forget to do your Google form. Thanks so much.